So hey guys, welcome to Clear and Crisp Coding, and in this video we would be discussing the solution of Codeforces Global round 9 step C problem, which was element extermination. So this was a really interesting ad hoc type of problem, and let's get start the problem. So here is the problem statement. You can read the problem, but if I explain the problem in simple terms without missing any important point, then the problem is something like this. So we would be given a permutation. A permutation is a sequence consisting of number from only 1 to n in any order, and what we can do is we can choose any two adjacent indices, that means I and I plus 1, and if a of I is less than a of I plus 1, that means the I plus 1th index is greater, then we can remove either of them. So we have an option of removing either this or this from the array, and then the remaining part would concatenate. So as it is given in the example, see if we see it I equal to 1, that means 1 is less than 3 as given here, then we can remove either 3 or 1. So let's suppose we remove this 1, then these two would be the only remaining string and would be concatenated, and if we remove this 3, then this would be the string. So the main question is that after doing this kind of operation, is it possible to make array of length 1? That means there should be only single element. Like here if we see there are two elements, but we want only single element. So it's asked that can we make it. So here is some given sample input output. So let's get to the explanation for better understanding. So here is the explanation. We will be understanding visually also. So assume that these three are separate cases, and these height represent the value. That means this is the greatest value, this is the second greatest value. So this height basically represents the greatest value. So let's first see some observations. So for n equal to 2, that means there are only two numbers. Like suppose there are n equal to 2 and 1 comma 2. So in this we can just simply say if the first number is greater, that means a of 0 is greater than is less than, sorry, if a of 0 is less than a of 1, then we can remove any one and the answer would be 1. But if a of 0 is greater than or equal to a of I, then we cannot remove anyone, so the answer would be false. So n equal to 2 we would be having to handle separately, and we will be seeing the code to get the better clarity. And these were also some cases that if the maximum element is present at 0th position, then we cannot move forward. So we will be covering this explanation, and then it would be becoming more clear. So basically what we can see is that with this operation we have to first the element to the right side, ai plus 1, would be greater than the element on the left side. So basically what we can see that we have to find some peaks, so peaks of the array. So let's suppose this was the array. So now if the PC of the peak, that means the position where it has the maximum value, it has the maximum value here and here, as compared to the adjacent we are finding the local maximas. So this has this and this has the local maxima. So now according to operation, with that is if a of I is less than a of I plus 1, then we can choose any of it and remove the other. So if we see this from here to here, that means from 0, 1 and 2 position, this 2 position has the maximum, that means the local maximum. So if we do an operation on 1 and 2, then a of 1 is less than a of 2, a of 1 is less than a of 2, so we can remove either this or this. So suppose we remove this 1 from here, then again since this was a local maximum and this was a starting point, so a of 0 would be smaller than this, so a of 0 would be less than a of 2. Then we again have options, so we can choose any of them. So here we have to play really optimally to select the one which really helps us in the future. So now what we can do is, so if we see this entire thing, this means this entire part, we can select one out of these three. That means these all three can be merged into just one. That means by first clubbing 1 and 2 we can take one out, from 1 and 0 we can take one out. So from all of these we can choose any of our choice, and the operation which we still have is a of I should be less than a of I plus 1, then we can remove any. So the optimal answer for us is that the element which is present behind, that means from 0 to 1 2 3 4 5 6, at the behind index, that means ith index, should be less. So if it is lesser than this, the element present ahead, then we would be somehow able to perform the operation further and reduce the size of the length array. So the most optimal out of these three, 0, 1 and 2, would be for us to select this 0th and removing all of these. Then for the when we would be performing the same operation ahead, we would be having better options as if we just did it with the same. And similarly, if we see from index 3, 4, 5, 6, out of these four, just we as we observed here, we can select any one. What does mean is, so first we will perform operation between 5 and 6, since this is the local maxima. Then we can get from 5 and 6, we can either choose 5 or 6. Let's say we choose 6 and we remove this 5. Then this 4 and 6 are clubbed together, are adjacent. So by performing operation we can choose either this. So we from this also we can choose of our choice. Then if we see from this we have chosen only 2, from this all we have chosen 2. So from this we can choose any one of them. But what we have to see is that when this would be forming the ith index, then this would be forming the I plus 1th index. Then if this condition hold, then only we would be able to further reduce them to only one term, that is by deleting either of them and by performing this operation. So we at this position we want a number which is greater than 2, which could be any of these position. But again, if we think most optimally, then this position, that means the maximum of all. If suppose this was the greater than 2, then this would definitely be greater. So if we just check here, that means the local maxima, if it is greater than 2, then we would be taking this element at 6th position. And since this condition will hold for 2 and this, then we can also reduce by choosing any one. So we have reduced the array to length 1, length equal to 1 using these operations. Thence the answer is true. So what is the main observation is that we have to choose the minimum from the first, and then so minimum was 2, and then from the remaining we have to check that the maximum out of these, because the most optimal is maximum to perform this operation, should be greater than the chosen minimum here. So 5 is greater, then we can also again reduce to 1, that means 5 or say 2 or 5, anyone we can choose, and the length would be 1 and it would be satisfied. So this was the main observation, that choose the minimum, that means the 0th element here, and then from the others local maxima choose the maximum and then compare it with the first. So now let's take to this example. This has some more cases which we need to see. So if we see for this would be just similar to this. Let's number 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So if we see this part, this is similar to this. So from this we have selected the 0th position. Okay. From this also we were selecting the 0. I think I wrote 2 there. That was my mistake. So from this entire we are selecting just the 0th one, which is this 0. Okay, so do make that correction. So from here also we would be selecting this 0th, and then from the remaining, that means the minimum. So 0th is the minimum position, so we would be selecting that only. And if we selected this minimum, then if we see this thing, this is also forming the same structure as this, so we can select any of them. But as we discussed here, the most optimal one was to select the maximum. So from this we can select the maximum, which was 5, and we can see that this is still valid. So by selecting this, what we mean is that we would be removing this using these operations. As we discussed here, we would be doing first 1 and 2, then 1 and 0, and selecting the smallest only. Here and here we would be doing between this, selecting 5, here selecting 5. So by this we would be getting 5, by this we would be getting 0, and again by doing this we can do an operation on these two and we can further reduce it. But similarly, but what we discussed is that we are just looking at one local maximum, we have to also look at other local maximums. So here this is one local maximum, this is another local maximum. So this also would always be compared with the minimum, that is the 0th only. So every position is compared to the 0th element. And also what we have to see is that after local maximum, if there is some element that is in the last position, we also have to compare it to the 0th position, that it should be greater for answer to be yes. Since here it is less, then answer would be no because of this and it cannot be reduced. Similarly, from this by performing operation we would be getting the 0th position, and with this local maximum we would be checking, then with this we would be checking. So this was the entire code. So first here I think I made some mistake in the early explanation. It should be always 0, and then from the later on we are selecting just the maximum one and comparing it with the first position. And if there is a smaller last element, we are also comparing that, because that could also be a problem. Because suppose here here was this and this last was smaller, so this would not be valid. That means the element at 0th position would be not be greater than the element at 9th position would not be greater than the element at 0 position. So this would not be satisfied and we would not be able to see it. So let's see the code for better clarity. So code is also the same which we just discussed. So for n equal to 2 we have handled the edge case, and if any 0th position have n element and the last position has 1, so we are also printing no. So what we are finding is we are finding the peaks here. So a peak is, let's suppose this is a peak if it is greater than this and this. That means if it is greater than both of the adjacent. Also by finding the peaks we are storing in the max peaks. And here is one important point which we just missed in the explanation, and that is, suppose we have something like this. This is the starting point, and here it is the first maximum, the second local maximum, and the third local maximum. So if we have more than one maximum, so from this 0 1 2 3 4 5 6 7, so if we see for this we would be getting the minimum value from here, and then we would be having one local maximum here, one local maximum here. But here if we see this sixth one, this sixth local maximum is also greater than this. So by first combining these two we would be selecting 6, then by combining these local maximum also we can select it. So we have to do is we have to select the rightmost, that means the rightmost maximum, and then compare it with the minimum, rightmost local maximum. And since this is also remaining, this would also be compared. This is the last value which we discussed here, that the last would be compared separately. So we are first of all inserting this last value into the vector pair which we will be using for sorting. Then we would be sorting it and reversing it as we want in the reverse order, that means decreasing order. And this right variable would be the rightmost peak which we have covered. And since it is already sorted, so we would be getting elements in the sorted order, and we would be comparing with the rightmost position which we have already covered. So suppose when we would be coming this would be a peak, but this one would be coming the first, because since it is greater and we have sorted it in this order only, so the higher one would come first and we would be bringing right here. Then after that when 4 would be coming, but then right would already be made 6, so this condition would be invalid, then 4 would not be included in our peak. And then what we are just doing is comparing it with the 0th position which we just discussed. Everywhere we are just comparing with the 0th position. If anything is invalid, then we are marking it as false, not okay, and just printing the answer. So I hope the explanation was clear. If anything is still unclear, do let me know in the comment section. I would be really happy to help you. And do like this video and give it a thumbs up, and subscribe to the channel, as we would be regularly posting competitive programming material from various live contests. Thank you guys. Thank you for watching.